Alright guys, welcome to lesson 5.11. Today we're going to learn how to read graphs of f prime to make some conclusions about the graph of f. So first of all, let's review some key concepts here that we've already discussed, but just wording them in a way that'll be helpful for our lesson today. So first of all, interpreting graphs. And make sure you guys are filling in your blanks here as we go. If a graph is above the x-axis, that means the function is positive. If the graph is below the x-axis, that means the function is negative. If the function is on the x-axis, that means the function is 0. If the graph is sloping upwards, and I'll draw a picture of that here. If the graph is sloping in an upward direction, then we say that the function is increasing. And if a graph is sloping downwards, like that, then we would say, of course, that the function is decreasing. All right, so we'll go ahead and continue here. Let's go ahead and take a look at part B. So now let's take a look specifically at what f prime tells us about f. So the key fact here to keep in mind is the fact that f prime is the slope of f. And keeping that in mind should help all these things here be fairly evident. So if f prime is positive, that means that f has a positive slope, and that would mean therefore that f is increasing. Okay? If f prime is negative, that means that f has a negative slope, and therefore f would be decreasing. If f prime equals 0 or is undefined, that means that f has a critical value there. If f prime changes from positive to negative, in other words, f is going from a positive slope to a negative slope, that means that f would have a relative max at that point. And if f prime is changing from a negative slope to a positive slope at a specific point, then we would say that f has a relative minimum at that point. Okay, so taking all those facts, we're going to go ahead and move into an example here. All right, so number 1 says the function f is defined and differentiable on the interval from -4 to 12. So we're starting here at x equals -4, and we're ending over here at, nope, not 12. Let me adjust that. We're ending at 3. So there's that. And this is not a graph of f, though. This is the graph of f prime. That's kind of an important thing to take note of. So I have a graph of f prime, and all these questions are going to basically be asking me to use this graph of f prime to come to some conclusions about the graph of f. So the first thing is saying is identify all intervals for which f is increasing, and then explain your reasoning. Okay, so up here, we identified the fact that f is increasing whenever f prime is positive. Okay, and that's significant because f prime will be positive anytime that function is above the x-axis. Okay, so let's come down here and let's find any time that this graph is above the x-axis. That means that f prime is positive. And so a big part of today's lesson is not just being able to identify things, but also being able to explain your reasoning. So you want to make sure that as you guys are writing down your solutions to these things, that you are writing them appropriately, because this is actually a new lesson that I've made a lesson officially, where I'm trying to help you guys learn how to express this appropriately for FRQs, because these are very common FRQ questions. So we would say f is increasing when f prime is positive. Now, the next part you don't really have to say, so I'll just speak it, but I'm not going to write it. F prime is positive when it's above the x-axis, but you don't need to write that, okay? This occurs on the interval -4 to 1, negative 1. Now you'll notice that I used a parenthesis on the 1, but a bracket on the 4. Why did I do that? At x equals 4, this dot is above the x-axis. But at x equals negative 1, it's right on the x-axis. So here I can't say that negative 1 is actually above the x-axis anymore, which means that f prime is not positive right at negative 1, but it is right up to that point. And then after that, we could say those are all places where it's increasing. Okay, so this is how you would answer number 1. Okay, so write down your answer because I'm going to be erasing these as I go. Let's go ahead and move on to the next part. Identify all intervals for which f is decreasing. Now this is the opposite. So obviously if f is increasing when f prime is positive, and f prime is positive when it's above the x-axis, then f is decreasing when f prime is negative, and that happens when f prime is below the x-axis. So this green region here is where we are below the x-axis. So we would say f is decreasing. I'll call this number 2. F is decreasing when f prime is negative. And I'm not going to write this next part, but I'm going to say it just for teaching purposes. F prime is negative when it's below the x-axis. So I'd say this occurs on the interval. Now it starts here at negative 1, right? But it's not actually below the x-axis at negative 1. It's right on the x-axis. So I'm going to give that a parenthesis. Got off my thingy here just a second. So it starts at negative 1, but not including negative 1. And then it goes all the way up to 1. Now you'll notice at 1, it's on the x-axis again. So I'm going to go ahead and say 1 there. So from negative 1 to 1, and on the interval from 1 to 3. Now the 3 is actually still below the x-axis, so I'm going to give that one a bracket. Okay. Now you may ask, is it okay if I just say from negative 1 to 3? I would say this is a better answer because at 1, it's actually not below the x-axis, it's on it. So it's only below from here to here, and then from here to here. It's not below the whole way. It stops and it touches the x-axis halfway through. Nevertheless, there's our answer, and that's how you'd write your solution there. All right, let's go ahead and take a look at the next question here. It says, identify the x-coordinate of any critical values of f of x and explain your reasoning. So let's come back up here to our explanations here. And I don't think I included that there. Let me see, did I? Oh, yes, I did. There it is. Good. All right. F has a critical value anytime f prime is 0 or undefined. Okay. Now, a function is 0 whenever it's on the x-axis. We're not going to really worry too much about undefined in today's lesson. It just won't really occur very often. So basically, anytime the graph of f prime touches the x-axis, which is here and here, that's a place where f prime equals 0. And if f prime equals 0 at those places, that means that these points must be critical values for the graph of f. So let's go ahead and write that. F has a critical value f has a critical value when the derivative is equal to 0. That happens when the derivative graph is touching the x-axis. And this happens at negative 1 and 1 for the x values there. Okay, let's go ahead and take a look at number 4. Number 4 says, identify the x-coordinates of any relative extrema of f. Okay, so once again, let's go ahead and scroll back up here to the top and see where the relative extrema are for f. It says here f has a relative max and f has a relative min when the slope changes from positive to negative or from negative to positive. Okay, so let's go ahead and start with just, well, I guess we'll kind of just do them together. So let's go ahead and jump down and see what that looks like. Now, we already know that f prime is positive here, and it's negative here. Okay? And so where are we changing from a positive to a negative? Well, that would happen right here where we're going from green to red is right there. So we have some kind of a relative extrema at that point. Now, remember when you're reading these graphs, we always think of going from left to right. So I'm going from green to red. In other words, from positive f prime to negative f prime. So when you go from a positive slope to a negative slope, that is a relative max. And so here's what we would write. We would say f has a relative max when f prime changes from positive to negative. This happens at x equals -1. Now, nowhere on this graph is it changing from negative to positive. In other words, it's not going from below the x-axis and back up again. And so there's no relative minima on this particular graph. Okay? And so that's it. That's for our first part of the lesson. I'm going to stop there and let you guys do a student practice now. We are going to do 5 through 8 afterwards, but for now, let's jump up to student practice number 1. And I would like you guys to please do numbers 1 through 4. So pause the video here and do numbers 1 through 4. When you unpause it, you will see the solution. All right, guys, so I'll let you go ahead and study these answers here, compare them to your answers, and we'll go ahead and move on to the next set of today's work. Pause the video if you need to study these a little bit longer. All right, so let's take now a look at part C, back up to the first page of our notes. We're going to look now at what does f prime tell us about f double prime, and from that we can look at what f double prime is to tell us some stuff about the original graph of f. So here's the key fact. F double prime is the slope of f prime. That's one thing to keep in mind. And also f double prime tells us about the concavity of f. So from that we can conclude the following things. If f prime is increasing, so if the graph of f prime is going in an upward direction, that means its slope, in other words f double prime, is positive. And when f double prime is positive, that means that our graph of f is concave up. Likewise, if f prime is decreasing, that means f double prime is negative and f is concave down. Now, suppose that f prime has a horizontal tangent line. So for instance, like if I had this, it would have a horizontal tangent line grazing it at that point, right? That would mean that f double prime equals 0. And that means that f may, the key word is may, have a point of inflection at that point if f double prime is changing signs at that point. In other words, f double prime is going from positive to negative, or another way you can think of it is f prime is going from increasing to decreasing. Okay? If f prime has an undefined slope, in other words, it's a vertical tangent line or a cusp, then that means that f double prime is undefined, which means that once again, f may have a point of inflection, but once again, that's only true if f double prime is changing signs at that point. Okay, so keeping that stuff in mind, let's go ahead and jump into some other stuff. All right, so let's go ahead and pick up where we left off with here with our example 1, and we're going to do number 5 here. Identify all intervals for which f of x is concave up. Explain your reasoning. So coming back up here to our chart, I see that f is concave up when the second derivative is positive. This happens on the graph of f prime whenever it's sloping in an upward direction. So basically, I need to find anywhere on my graph of f prime where I have a positive slope. So for instance, here we've got a positive slope, and here I've got a positive slope. So in those intervals, since f prime is positive, that means that since f prime is increasing, that means that f double prime is positive, which means that f is concave up. So we need to write that out as an answer. So here's how we'll do that. Number 5. F is concave up when f double prime is positive. This happens. Now the next part I'm going to say, but I'm not going to write because it's not required. But this happens when f prime is increasing. But we don't need to say that. We'll just go ahead and say this happens at, or I should say on, the intervals -4 to -2 and 0 to 1. Those are the two regions that I've got highlighted here. So f is concave up when the second derivative is positive. The second derivative is positive anytime the graph of f prime has a positive slope. And that happens on these two intervals that I've highlighted here. Okay? So let's go ahead and do the same thing now. The next question is the opposite. It's asking where is it concave down? Where is f concave down? And by the way, I just said something that I don't ever want you guys to write, and you might want to make a note of that. On these problems, don't say it. On any problem, really. Don't say it. Why? Because when you say it's increasing, the people grading your AP papers will say, what's increasing? Is it f prime, or f double prime? We don't know what you're talking about. So if you say it, you've automatically disqualified yourself from getting any points. Don't say it. All right? All right, so back to our question here, number 6. We want to find all the intervals for which f is concave down. Well, f is concave down anytime the second derivative is negative. The second derivative is negative anytime f prime is decreasing. So anywhere on this graph where f prime has a negative slope, f double prime is negative, and therefore f is concave down. So we're ready to go ahead and write that answer here. So just so you guys know, at this point here at -1 and also here at 1, we would say that f prime is not decreasing because there's a cusp there, that the slope isn't doing anything. The slope doesn't exist at a cusp. So we can't say it's decreasing at -1 or 1. So we're going to use some open parentheses there. So here we go. We would say f is concave down when f double prime is negative. And by the way, another way you could say something's negative is by doing that. You could also say positive by reversing the inequality. Now, the next part I'm going to speak, but you don't have to write. F double prime is negative anytime f prime is decreasing. And that's what I've got highlighted here. So now we can continue to say this happens on the interval from -2 to -1. I am going to stop at -1, even though it keeps decreasing after that, because at -1 there's a slight bit of a cusp there, and the slope isn't defined, and therefore we can't say that it's decreasing, and therefore we can't really say that f double prime is negative there. All right. And the interval from -1 to 0, and finally from 1 to 3. Now I'm not going to put brackets just because endpoints, you could put a bracket, wouldn't be bad, but the question is the function decreasing at this point? Well, it's hard to say what's going on at this point because there's nothing happening after it. Would it keep decreasing or would it start increasing? We have no idea. It wouldn't necessarily be wrong to put a bracket. I'm just going to stick with a parenthesis just to be safe, though. But there you guys have it. So that's the answer, number 6. Now, our next question is asking us to find the points of inflection. Points of inflection. So coming back up here to our notes, points of inflection happen at horizontal tangent lines and cusps. But more importantly, it's happening anytime f double prime is changing signs. And that's happening anytime f prime changes its slope. So anytime f prime is changing its slope from positive to negative or from negative to positive, that means f double prime is changing its sign. And if f double prime is changing its sign, that means the curvature of f is changing from up to down, and that's when you have a point of inflection. So let's go down to our graph and let's find the places where f prime is changing its slope. So we've already said that this is a negative slope, this is a negative slope, and this is a negative slope. And we've also already said that this is a positive slope, this is a positive slope. And so the question is, at what points on the curve is it changing its slope? Well, that would happen here, and here, and here. It's at these three places where we go from a positive slope to a negative slope, or vice versa. So since f prime is changing its slope at those points, that means that f double prime, I think I might have misspoke. I'm going to reword that. At these points, since f prime is changing its slope from positive slope to negative slope at these points, that means that f double prime is changing its sign at these points, which means that the curvature of f is changing at these points, which means these points are points of inflection. So how do we write our answer here? We would say f has a point of inflection when f double prime changes signs. And as a special little detail, f is defined. Now, the problem here says that f is defined, so technically you might be able to get away with not saying that, but to be safe, that's technically true. It's possible for a function to change its curvature and f is not defined, in which case that's not a point of inflection anymore. But anyway, I'll come back to that in a second. So f has a point of inflection when f double prime changes its signs, and that means where f prime is changing its slope, and this happens at x equals -2, 0, and 1. Now, that's the answer number 6, but just so you guys know, I'll give you an example. The reason why it's important that you understand that f has to be defined is because you could have a horizontal tangent line, vertical asymptote is what I meant to say, a vertical asymptote, and a function could be concave up on one side and concave down on the other. Now, there's no point of inflection connecting these pieces. These pieces are not connected at a point. And so there's no point of inflection even though the concavity is changing. So even though f double prime changes signs, if f's not defined, then that can't be a point of inflection. So it's just to stay on the safe side, it might be good to say that, but since it's in the directions, you might get away with not saying it. Okay. All right. So there's that. Now we're going to do one more thing before we cut you guys loose and let you practice. These questions happen sometimes, I've seen. It asks you to find all intervals. It looks like I've got a repeated question here, if I'm not mistaken. Oh, no, here it is. We're good. Number 8. Identify the intervals where f is concave up and decreasing. So we need to find two different things simultaneously. Now, we've already done both of these. The issue, though, is we need to do them again and find where they overlap. Okay, so I want concave up and decreasing. So let me highlight those again. Concave up and decreasing. So concave up, when does that happen? That happens when the second derivative is positive, and that happens when my graph of f prime up here has a positive slope. So here is concave up, and here is concave up. Now, f is decreasing. Now, we haven't seen that in a little while. We saw that way back here on number 2. Oh, that was a terrible highlighting job there. We saw that on number 2. We saw that f is decreasing anytime the derivative is negative. And the derivative is negative anytime it's below the x-axis. So it's below the x-axis here and here. Now, the question is, where is it both concave up and decreasing. In other words, pink and green at the same time. Well, that's happening right here, right? So that's the interval from 0 to 1. So how would you write your answer for that? Number, I guess we're on 8, right? F is concave up when F double prime is positive, and F is decreasing when F prime is negative. This happens on the interval 0 to 1, and that's it. Okay, so that is that. Let's go ahead and set you guys loose here on a student practice. So I'm going to have you guys do this. Have you guys do numbers 5 through 8 for this particular function. And go ahead and pause the video here. And when you unpause it, you'll see the solution. All right, guys, and so here is the solution. I'll let you guys go ahead and study this one. Number 8 is probably a hard one. I'll go through that really quick. G is concave down when G double prime is negative. Now, G double prime is negative anytime the slope of this graph is going in a downward direction. So this whole piece right here is where my G prime graph is a negative slope. Therefore, G double prime is negative, and that means that G would be concave down on those regions. Next, G is increasing anytime G prime is positive. Now, G prime is positive anytime it's above the x-axis. So that's here, here, and here. And the only place where those two things are happening simultaneously is where the green and the purple are overlapping, and that's from 1 to 2. Okay? So other than that, I'll let you guys study the rest on your own, and then you can call it a day, and we'll see you guys in class to practice.